Hello everyone, welcome to my channel Electronics Plus. Today I will show how to interface NI6008, a multifunctional data acquisition card, with LabVIEW and acquire analog signal using NI6008 and LabVIEW software. Before that, I will give a brief introduction about NI6008 data acquisition card. So let's start it. NI6008 is an USB powered data acquisition card and it communicates with LabVIEW via USB as well. Therefore, it is called NI USB6008 DAQ card. It is called a multifunction I/O DAQ card because it has both analog and digital I/O channels. The analog channels are in one side and digital channels are in other side of data acquisition card, and they are well labeled. Let's come to the analog side first and see the specification. NI6008 has 8 single-ended analog input channels from AI0 to AI7, and it has 12-bit ADC built-in inside the DAQ and having sample rate of maximum 10 kilosamples per second. We can choose the sample rate as per our requirement in DAQ Assistant configuration panel. Here, two single-ended channels can be combined to form one differential channel. You can see here AI0 and AI4 forms one differential channel together called AI0 plus minus. Like this way, we have 4 differential channels from AI0 plus minus to AI3 plus minus. NI6008 has 2 analog output channels also, labeled as AO0 and AO1, and they have 2 12-bit DAC built-in. We can generate the analog signal like sine wave, PWM in LabVIEW and send them to the physical world via AO port. Let's come over to the digital side. Here there is a built-in 5-volt power supply with maximum current of 200 milliamps. There is also a 2.5 volt supply for external reference and self-testing purpose. Besides that, it has 12 digital I/O channels. They are called I/O channels because each channel can be used for both input and output purpose. These 12 channels are clubbed in 2 ports, that is port 0 and port 1. Port 0 has 8 I/O lines and they have been labeled as P0.0 to P0.7, and port 1 has 4 lines and labeled as P1.0 to P1.3. The maximum voltage level of digital signal the DAQ can handle and generate is 5 volt. There is also one PFIO slot which is used for specific purpose, either for digital trigger input or event counter input. I will discuss about this in my future video. In today's video, I will show the analog signal acquisition. We can demonstrate this operation by measuring the voltage of a port at various shaft positions. For that, I have taken one 10K port where the 3 wires are connected to 3 terminals of the port. Now connect the port with the data acquisition card as per the circuit diagram. The extreme left and right terminal are going to connect it to the 5V and ground of the DAQ respectively, and the middle terminal is to be connected to any one of the I/O channels, let it be AI0. Now connect the port to the data acquisition card. The red wire is going to connect to 5V of the data acquisition card, and the black wire is going to connect to the ground pin of the data acquisition card. The middle wire, that is the yellow wire, is going to be connected to the AI0 channel. That's it from the hardware side. Let's switch over to the computer for the software work. Let's open the LabVIEW software first. I guess you have little bit of knowledge on LabVIEW. It is not at all a difficult software to learn. After watching 2-3 videos, you can easily get it. When the LabVIEW software is launched, first the LabVIEW initialization window will appear. Click on the Start LabVIEW. Then go to the File menu and click New VI. As soon as the New VI button is clicked, 2 windows appears. One window is called the front panel and the second one is called the block diagram. Generally, in the front panel you can find the user interface tools like controls and indicators. In block diagram you can find the functions and programming tools. I am going to use the Express VI tools for data acquisition. So right click over the block diagram and go to Express, and from the input drag and drop the DAQ assistant. It starts initializing. Then I'll give the permission to access, and the new create task window comes out. Then click on acquire signal, and in the acquire signal click on analog input. In the analog input we are going to acquire the voltage signal. There are number of analog signals are there, but our data acquisition card only supports the voltage. Then our USB6008 port is being detected, and the number of I/O input channels are being shown here. We are going to use AI0, so check it and click on finish. Then the DAQ assistant configuration panel comes out. Here we can change the voltage input setup. The maximum voltage should be 5V and the minimum voltage should be 0. The terminal confirmation should be RSE, means reference single-ended, because all the voltages, all the signals we are going to measure is with respect to ground. In the timing setting, there are a number of acquisition modes: one sample on demand, n samples, continuous samples. In n samples, there is two separate parameters, sample to read and sampling frequency. We can change it here. But in today's experiment, we are going to use the one samples on demand. Our VI will take the samples as per the requirement. In the connection diagram tab, we can see the hardware connection to the external source. In the RSE mode, there is a ground terminal and one is connected to channel. But if we change the RSE to differential mode, then the ground terminal will be switched to AI0 minus. Now everything is fine. Check it to RSE mode and click on OK. Now our Express PI is going to build. Now to acquire continuously the data, we are going to put the data assistant in a while loop. To control the execution, we have to stop the VI. So in the conditional terminal, right click over there and click create control. So a stop button will be created and the corresponding button will appear in the front panel. Resize it and drag and drop to the middle position. Right click over the front panel and in the numeric control, click the new meter. Then resize it and drag and drop to the middle position. The range is from 0 to 10, it is default. Our input range is from 0 to 5 volt, so make it 0 to 5. As soon as the meter is dropped in the front panel, a corresponding function is created in the block diagram. The data which is accurate by the data acquisition card is going to be shown in the meter. So connect wire between DAQ assistant data terminal to the meter. Now we have to put some delay between the while loop iteration. So go to the timing, drag and drop, wait millisecond. In the input, create constant and give a value of 100 millisecond. Now it's almost done. Go to the file and save our VI. Now it's time to check our VI and the hardware. So let's run the VI. Now rotate the shaft of the pot. when the shaft is being rotated, the corresponding voltage is being fed to the data acquisition card, and correspondingly the meter pointer moves over the meter, shows the accurate voltage. In order to see the exact voltage, we have to enable the visual display, that is the digital display of the panel meter. Right click over the meter and enable the digital display. Now it's done. The digital indicator shows the corresponding value of the analog pointer. Now run again the VI and rotate the shaft of the pot. Now as per the rotation of the shaft, the pointer moves as well as the digital meter shows the corresponding values in volts. In this process, any analog voltage signal, it may be output of any sensor or any circuit, can be accurate using NI USB6008 data acquisition card and LabVIEW together. So that's it from today. If this video helps you, then like it and subscribe it to my channel. Thank you for watching. Bye.